and roll, guys and girls. Okay, so in the trigonometry section, there is always going to be a simplification question on using the reduction formula. Okay, and the reduction formula basically just takes angles that are greater than 90 and reduces them to angles that are smaller than 90. And we generally use we use something called the cast diagram. So CAST. And what we ask ourselves is, in each of these quadrants, angles that form into each of the quadrants have a particular form. So any angle that is in this quadrant, quadrant 1, will have the form x. In this one, 180 minus x. In this one, 180 plus x. And in this quadrant, 360 minus x. Now, the reason we say that it has these forms is when we use the reduction formula, we're always interested in how far away is the angle from the nearest horizontal. So as an example of this, imagine I want to simplify the sine of 150. To visualize the angle of 150, the angle could look something like that, right? 150. In order to reduce the expression, the sine of 150, because 150 is an angle greater than 90, we say, how far is it from the nearest horizontal? And the nearest horizontal is 180. So if we use this formula, you'll see that 180 minus 150, so let's do it here, 180 minus 150, that tells us how far away this angle is from the nearest horizontal. So what is the sine of 150? So we ask ourselves, in this quadrant, is sine positive or negative? And because of the S in this quadrant, we know that sine is positive. And then we just say the sine of 30. Now just check on your calculator that you see that the sine of 150 and the sine of 30 gives you the same amount. And give me a thumbs up when you guys have checked that. Okay, so you believe me that it's possible to reduce something like that. Now, if I said to you, what is the cos of 150? So this is me just doing a bit of recapping before we start the question. The cos of 150 is not going to be the same as the sine of 150. Does anybody want to tell me why the cos of 150 is a little bit different when we reduce it? So I'd love someone to put their hand up and maybe tell me if I have to simplify the cos of 150 using this reduction formula thing that you see, what do you, okay, Hariva, you're on the money. In quadrant 2, so 150 is in quadrant 2, cos is negative in this quadrant because the only thing that's positive is the S. So we say negative cos 30. And so that's the reduction of the cos of 150. Nawazi? Absolutely. Okay. So that was my little warm-up just to get you guys in the mood for reduction formula. Now what I want is I want you to try and solve for me this exam type of question. But there's one other sneaky thing that you need to remember, and that is what's called your special triangles. And so I'm going to draw a special triangle on the edge here. Now you do need to memorize these to help you for this one. Okay, off you go. Try and simplify this expression without a calculator. And if you get stuck, I want you to raise your hand so we can have a conversation. Ask yourself, how do you visualize these angles? And if you reduce them, what would have to happen? And once you feel like you've done the question, then just put done in the chat. See if you can use my little, I gave you some drawings to help you visualize the different angles, and see if that can help you as you Who would like to, I'd love someone to help me with sine of 180 plus x. How do I reduce that part? Not the whole question. Who would like to help me get on the road to doing that? You can just pop your hand up and then talk me through it. It's so much quicker to just hear your voice than typing out is great, but I would love to hear your. So for me, the quadrant that 180 plus x in is quadrant number 3. So it's this first drawing over here, and it's x away from the nearest horizontal. And so I get minus sine x for that first bit. Nawazi, exactly, minus sine x. And then for the cos of 330, that is going to be this drawing over here. And I noticed that it's 30 degrees away, but in this quadrant, cos is positive. So this must be not the sine, it must be the cos of 30. So that's the cos of 30. And then the tan of 150 is going to be the one up here. So if that's 150, this must be 30. But in this quadrant, tan is negative. So it's negative tan 30. And then it's over the sine of x. Now, that's the reduction, and I'll give a moment for questions. But who would like to tell me what my next step is? I'd love to know from the class where my next step is for, because I've got to simplify this further. Okay, whose hand is up there?
Lysander.
Lysander, you want to unmute Lysander?
Sir,
Yes.
I want to know this circuit negative sine x.
Yeah, so you cancel out the sine x's, and you also cancel out the negatives. So then all you're left with is cos 30 times tan of 30. You know what to do from there. Because remember, we can't use a calculator, huh? Nice, Banolo. So remember at the beginning of the lesson, I said to you that there was, oh, I see lots of people's hands are going up. Okay, who's going to help me with this one? Can you unmute someone there, Level?
Gift is unmuted.
Okay, go ahead. Gift, are you unmuted?
Yeah.
What do we need? Hey, how's it going?
I have a question.
Okay, go ahead. Yeah.
So you canceled out negative sine x with a positive sine x. Is that possible? What happened to the negative?
Okay, so I canceled out a negative times a negative is a positive, And then I also canceled out sine x over sine x. Canceled out sine x over sine x. Does that make sense?
So sine x became positive.
Yes, basically two
became positive.
Yeah. The two negatives became a positive, and then the sine x canceled each other out. So I see what Mike is saying. We use the special triangle. And so what we do is I will just draw the special triangle again. We know the cos of 30 is just going to be, so if we think of this as O, this is H, and that is A, the cos of 30 is going to be root 3 over 2, and the tan of 30 is going to be 1 over root 3. Let me actually draw it like this so you can see. And so we cancel out those, and our final answer is a half. Okay, awesome, Tandawethu. I love it. I love it. So that was the first question. Let's move on to a second question now. All right, so the second question of today, I'll leave the other stuff up on the board, but I'd like everyone to try and start doing the second question now. Off we go, ladies and gentlemen. Let us apply our newfound skills. And then as you're doing this, please do raise your hand and ask a question. I'm here to help you. So is Lebo, and we, yeah.
Mr. S, we have a question from Owami.
Yeah. Owami, hi.
Hi, sir.
What can I do for you?
Sir, the thing is that instead of doing it your way, I converted 10 into sine over cos, then I canceled out, but I still got a half. So
perfect. In some ways, I think I like your way more because it kind of saved you some extra work. So
yes.
Perfect. No problems.
So it's correct. Oh, thank you, sir.
100% correct. 100%. Yeah. In math, sometimes there is a simpler way to do it. I won't always see it, but there's no problem. And the fact that you got the same answer is awesome. Well, it means we're both correct, thankfully. Okay, let's try and do the second one. I think of these as 6 little questions. So ask yourself, how do you deal? I like these little drawings, but how do you deal with each of these things? That's going to be your challenge for this question. And you have to simplify this without the use of a calculator. So it's the same instructions as above. You can do it, ladies and gentlemen. You can do it. I like drawing these cryptic drawings to help you. Right. Okay, who wants to tell me how to deal with cos of 750? How do we deal with that? Okay, Mulalo, here's the trick. For 750, you start here and you go around once, 360, twice, 720, and then you get up another 30 and you get to 750. So the trick is that this first cos of 750 is in quadrant number 1. Whereas the tan of 315, which is this one over here, this is the second one. This is going to be in quadrant number 4. In this case, 30 is going to be important. In this case, 45 is going to be important. Yeah. So I hope that helps you along the way. Now, obviously, the CAST diagram is always in the back of our heads. I'm not putting in the CAST every time. But the very first one, you should get cos 30 because everything is positive in quadrant 1. Only sine is positive in 2, tan is positive here, cos is positive here. So the very first bit is cos 30. And the second one is minus tan 45. What do we think the cos of minus theta is going to be? It's going to be this drawing over here. How can we reduce that to something simpler? Who would like to have a go or ask a question? Or it's well done, Nawazi. Yes. Okay. So a negative angle it just means it's going from here. What quadrant are we in? We're in quadrant 4. How far away is it from the nearest horizontal? It's theta. And so that's cos theta. So that's line 1. Then the second one, 360 minus theta. Now, what's going to happen there? Okay, so you go all the way around 360, and then you go back. And again, it's still just theta away. So for me, it's cos theta because it's in quadrant 4, and it's theta away from the nearest horizontal. And then sine of 300, that's this one here. This is going to be 60 away. So it's negative sine 60. And then sine of 180 minus theta, well, that's in this quadrant, and sine is positive. And so I get sine of theta. Okay, Amukalani, let's go to you. What is your question about this one? Yeah.
So, sorry for like moving back, but
No, it's
I
fine.
wanted to ask, can you please re-explain the cos of negative theta? Why
Yes.
it's positive theta?
No
Positive
problem.
cos theta.
Okay. When we think of a negative angle, we just think of it as going in the opposite direction. Okay. So if you think about, if I'm here and I'm going to go negative theta, it's just going to be going in this direction. The angle is still theta. It's just going in this direction. And do you agree that we're in quadrant 4 if we go in that direction?
Yes, sir.
Okay. Now in that quadrant, isn't cos positive?
Yes, sir.
Okay, so you're with me on that. So that's when we use the reduction formula to get cos of theta.
Oh, okay.
Because we
Thank
theta
you,
away.
sir.
Pleasure. Okay, now, next step, we cancel out the cos thetas. Now, and we are left with, what have we got left with here? We've got all these things over here. Now, the one thing that can be quite sneaky to do, although you could also use numbers, is that the cos, there's something called a co-ratio. And a co-ratio, you can either evaluate the cos of 30 using your special triangles, or you can use a co-ratio. So let me just show you what that is. So here's your special triangle. So 30, 60, 1 root 2. Or you can recognize, and I'm not going to go into this too deep today, but the cos of 30 is the same as the sine of 60. And if you do that, if you make that substitution, right? If you go the cos of 30 is the same as the sine of 60, it will save you a little bit of time because it'll knock that out. But if you put the numbers in for sine of 60, you'll still knock it out. So there's no problem with that. Then we have negative over a negative, so that cancels each other out. And all I'm left with is the tan of 45 over sine of theta. But we still have to evaluate the tan of 45. And the tan of 45 is just O over A. So it's just 1 over 1, which is 1. And so that is my final answer. 1 over sine of theta. If you subbed in values earlier, you would still get the same answer. Now, that's a tough question, hey? So I'm not, and here's the thing, is that even if you get some of this wrong, you can still get like 5 out of 7. So even if you don't get a perfect answer, still, and the other thing is always write your special triangles on the side to show your teacher you know how to use them, especially if they've said you can't use a calculator. Okay. Give me a thumbs up if we're okay and ready to move on. Thumbs down if you feeling a bit lost. Okay. I'm going to move on to a different type of question because I feel like we've done what we can on this type of question, and it's time for a different one before we go to the break. So let's go to a trig identity question. Let me go to something like, what should I use that one? Okay. Let's try and do something like this. Okay. We'll do a squeeze in one before the break, and then after the break, we'll do something different. If we look at this, a trig identity question works like this. You normally have one side, we call it the left-hand side, and then we have the right-hand side. And we work with the one side to try and show that it is the same as the other side. And we normally start by looking at the more difficult side. So for me, in this case, I would start by saying the left-hand side is sine x times tan x plus cos x. And then my journey in life would be to try and transform this to look like the right-hand side. Okay. Now, before I go up on my journey, there's some important trig identities that I need to load into my memory. What are the important trig identities that you need to know that will help you in this type of question? And I'd love some comments from the class. Who knows some trig identities that might be like important tools for the job? Can I phone a friend? Who's gonna let me know some identities that might be helpful? Okay, Owami, I like it. The tan of x is the same as the sine of x over the cos of x. Yes. And then the other one, I don't think it's going to come up now. It's that sine squared x plus cos squared x is 1. And you can also rearrange that one sometimes to help you. So the tools for the job for this type of question, what I'll call proving identity questions, is those two identities and subbing them in, and then moving things around using clever mathematical techniques. Okay, so if I look at this left-hand side, what is my first step going to be? I want to know from the class. I don't think there's too much I can do except only one thing. What's the only move I can make? Yeah, Amukalani, let's go to you.
So I think you should make tan x sine x over cos x, I think.
Perfect. You just got yourself 1 mark guaranteed. Okay, so even if you have not a cooking clue how this question works, if you had made that substitution, you would have 1 mark in the bag. Now remember, there's only 4 marks for this question. So to always do that. Okay, so let's do this. Sine x, and then this is going to be sine x over cos x, and then this is going to be cos x. Okay, now, that is a great first step. You've got 25% in the bag. Now, what I like to sometimes do is think about where am I going in my journey? And I'm going to this. And the right-hand side is only 1 term. It's 1 term that sits together. At the moment, I have 2 terms. There's a term over here, and then there's a plus, and there's this. And I almost need a way to glue these 2 together without breaking the law. So I want to know what do I need to do? So that, Mike, there isn't 2 sine x. Okay, well, what I did was I replaced the, should I write it like this? Okay. This is sine x over cos x. And I write anything over 1 like that. And so that's how I would get, maybe I'll even write it like this: sine squared x over cos x plus cos x. So that's the substitution step. But now I need a way of bringing these two together. Does anybody have a technique that they think maybe they could? I'll give you a little hint. I'm going to put this over 1. Have I changed the cos x? No. So why am I putting it over 1? Well, I think I'm going to use something called a common denominator. When I want to add 2 fractions together, I use something called the common denominator, but I need to almost create my common denominator here first. Does anybody have an idea how I can do that without breaking the law? Yeah, William, let's go to you. What do you think, William?
Can you hear me?
Loud and clear.
All right, so in order for us to, because we put cos x over 1, it'd be best if we multiply the denominator of cos x by cos x.
Yeah, so I think what you're saying, William, is if you multiply the top and bottom, if you multiply a fraction by 1, cos x over cos x is 1, you can artificially kind of create the situation where you have a denominator of cos x. Is that kind of what you're saying? Have I understood you correct?
Yes, sir.
Perfect. Okay, now that you've got your common denominators, what is your next step going to be?
My next step would be to put sin squared x plus cos squared x over cos x all together.
You are winning at life. Yes. Okay, now I'm going to hand this final bit to someone else. What is the final step I need to bring this question home? Yeah, Malalo, let's go to you.
Hi, sir.
No.
Wouldn't you use the second identity that says sine squared x plus cos squared x is equal to 1?
Yes.
Meaning the thing would be 1 over cos x, the answer.
Perfect. And why does that make me very happy?
Because it's equal to the right-hand side.
Yes, all 4 marks in the bag. Thank you very much. Okay, now it does take practice with these types of questions, and I'm not going to obsess about them today, but the basic technique that I've shown you here, where you work with the more difficult side, and you basically you're always going to use these 2 identities, and then there's normally like a little mathematical trick. Like William recognized it here, that I had to create a common denominator. Okay, but that was great. Okay. We've been working really hard. I'm going to leave this on the screen, but what I want is everyone to turn their cameras on, and I want to stand up, and I want us to stretch out because our brains need a break. So stand with me and just,
Guys, please join us in the stretch. Put your cameras on. We'd love to see your faces.
Stretch it out. Just stretch it out.
Give your mind a break.
There we go. Oh.
Yes. Shout out to William. Shout out to Gift. Come on, guys. Don't be shy.
You should be getting FOMO right now. Forget about social media. Like exercise FOMO.
Yes.
Oh, my brain. I can feel my brain. I just got 10% cleverer. Oh.
The juices are flowing.
Oh. All right. Oh, I feel like maybe we should stretch for like a full minute, like as a rule going forward. So, oh, awesome. Okay, and then let's do a quick little brain break. I've gone back to the classics. Who can figure out the answer to that? Yep, a duck is 10. In this world, a duck is 10. I like it. Now, what about, is that a, I don't know what that, is that a pig? No, there's a cow and a pig, yeah, and a chicken. No, that's a duck. Sorry, it's a duck. So, William, I would agree with you that this is 5. How much is a cow worth? I see some people are already locking in their final answers. We'll see in a moment if they were correct, if they will be declared the champions. 1, 1, 1, 1, 1. I agree. Okay, so what is the final answer? Kinas, I see your answer. Gift, Njongo, I get, because of BODMAS, 5 times 10 is 50, and then take away 1, and the final answer is 49. What a bunch of good students. Look at that.
Awesome,
49.
guys.
I feel like these types of puzzles, if anybody of the Watobe students ever get these, they're going to be like, game over. I've done so many.
Definitely.
Okay, well done, everyone. Well done. That was good. I feel like I need to find some new, we have some new challenges. Okay, you know what I'm going to do is, instead of doing an identity question now, let's go to a trig equation question, if I can find one. But let me make one up. I'll make one up for us, because I feel like that will be more helpful in general. So if I give you a trig equation like this, the sine of x is equal to minus 0. Let's actually say the sine of x equals 0.4. I want to know, can you find, I'll say solve for the general solution? And I just want to go through this method with you. So step 1, when doing this, is going to be finding what's called the reference angle. Okay, so step 1 is find the reference angle. And the way we get that is we ignore any negatives. Now, in this question, there is no negative, so it doesn't matter. But we ignore any negatives and we get an angle. So go to your calculator and go shift sine 0.4 and get me the reference angle. What is the reference angle that you get? I want to see in the chat that everyone gets, okay. So people are getting 23.58. Now that is not the general solution by itself, because the general solution needs to incorporate the quadrants where this is true. Now, sine x is positive in quadrants 1 and quadrant 2. And what I do, that means that I'm going to have 2 answers. There's going to be one answer in quadrant 1, and there's going to be another answer in quadrant 2. In quadrant 1, all angles are the form x, whereas in quadrant 2, all answers are the form 180 minus x. So what that's going to mean is over here, my answer is going to be, x is going to be 23.58, or x is going to be 180 minus 23.58, which according to my calculator is 156.42. Now, that is the solutions within 360 degrees. There are 2 solutions where sine x is positive and within 360, but to become a general solution, you have to add an extra little bit, what's called the period of the solution. And it just looks like that. And all this is saying, all the k times 360 bit is saying, it's saying, look, I could get another answer to this question by making k an integer. So if I made, for example, k1, then I could get another solution, which would be 23.58 plus 360. And that would be, 383. But for our purposes, the answer of a general solution would just be these two. Now that is the method. Okay, so Asimakis asked, how do we know which quadrants we're working in again? The way that I know what quadrants I'm working in is I ask myself, where is sign positive? So if I look at my question, sign is 0.4, which is a positive. Okay, so sign is positive in quadrants 1 and 2. So quadrants 1, because A is where it's positive as well. Let me show you how this is a little bit different when I have a negative angle, and then I'll give you one to practice by yourself. Okay, so let's say I want to know, here's my second question for the day. Solve for the general solution. I'm just using GS4. Let's say where the cos of x is equal to minus 0.4. So now I've got a new problem in that I've got to deal with the fact that it's negative, and I've also got to identify the quadrants. So first step, I want you to find me what's called the reference angle. Now, when you find the reference angle, you ignore any negatives, and there is a negative here. So find me my reference angle for this question. So shift cos 0.4. What do we get? Okay, so we get 66.42. Now, this is not the correct answer. It's just the reference angle. Now, the second part of the question is where we figure out which quadrants we're working in. And sometimes I do a little drawing here, an extra, and I often put a little label here. I ask myself, where is cos negative? Where is cos negative? Which quadrants am I going to be in? So cos is going to be negative in quadrants 2 and quadrants 3. Okay. In quadrant 2, angles are of the form 180 minus x, and in quadrant 3, angles are of the form 180 plus x. Now, this is going to be quite helpful. Okay, so I now go on and I want to find my answers. Now, what I do is I write a little number. So I go that for 2, and then I say, just to tell me what quadrant I'm in, quadrant 2 and quadrant 3. And the answer is going to be x equals 180 plus whatever the reference angle was. Sorry, not 180 plus, it's going to be 180 minus the reference angle. And then, or in quadrant 3, it's going to be 180 plus the reference angle. Now, the reference angle that you just found, the x, essentially, is going to be, well, give me a thumbs up if you're following me so far. Just want to check. So the reference angle, so we're subtracting for quadrant 2. Okay, question from Gift. Yeah. Okay, good. All right. Now, in order to get x, the answer here, this is going to be 180 minus 66.42. And so I get 113.58. Or, in fact, I'm going to go straight to the general solution. So plus k times 360, or x is equal to 180 plus 66.42, which is 246.42 plus k times 360, where k is an element of the integers. So that is the method we're going to use when we solve trig equations. And it's a very straightforward method once you get it into your heads, but I know a lot of students haven't quite mastered it yet. And so I want to practice that with you in the remaining time. A gift, yes.
So, sir, can you
Hey.
hear me?
Loud and clear.
Do we still ignore the negative of 0.4 when you are calculating for x?
Okay, you incorporate the negative. So you ignore it at the very beginning. So when I find my reference angle, I ignore the negative. But the negative is taken into account when we ask which quadrants is cos negative in. And it's negative in these two quadrants. And because I know that I'm in those quadrants, when I do this adjustment down here, it takes into account its negative. Does that make sense?
But how is it positive on quadrant 3?
It's not positive in quadrant 3. It's negative because at the very beginning, the question said cos was negative. As a test for the answer, put this into your calculator. Put the cos, just to show you that this works, put the cos of 113.58 in your calculator and see what you get. You should get pretty close to negative 0.4. So just to show you that this really is an answer.
Yes,
So put cos of 113.58. Do you get about negative 0.4?
Yes,
Give me a thumbs up. Does it work? Okay. So just to show you, it is answering the question. All right. Question from Njongo.
Sir, may I ask, like, what's the use of the k times 360?
So the k times 360 is just giving you all possible solutions. So if the question said, I only want answers in the range 0 to 360, then it would just be the 113 and the 246. But because trig functions are periodic or they repeat themselves, they have other answers that occur every 360. And so if you made K1, you'd get extra answers that are in a different range. Does that help? Okay.
Yes, thanks.
Let me give you one to do by yourself now. So let me say, I want you to find me the general solution for the sine of x equals 0.7. Off you go. This will be the last one for today. And I want you to practice the method that we've been dealing with here. And then I'll answer any
Teddy
questions.
has a question.
Yeah. Teddy, go ahead.
Good afternoon, sir.
No.
Sir, my only concern is that how would teachers ask this in the exam? Because sometimes
Yeah.
to find out later that you
I lost you there for a
is this like I'm saying, sir, sometimes we would write they would ask us questions where we're supposed to do this, but as students you wouldn't know what to do. So I want to know what is the topic of this? How will they ask us in the exam? Like for this, sir?
There's different levels of difficulty. What I'm showing you here is the foundational method, but sometimes the question can come like where, but I'm not going to go into but like sometimes they might write the question like this, and then you have to rearrange it so that it's sine of x is a half. So sometimes you have to do a little bit of algebra to get it into the correct form. But once it's in that correct form, then you can do the method that I'm showing you now. Okay.
Yes, sir.
So that's kind of, in the time that we have left, that's the best answer I can give you, is that you do a bit of work before, and then you can apply this method. If you get a question where it's just the trig function number, then you can go straight to this, what's the reference angle, what's the quadrants, etc.
Okay, sir. Thank you.
Okay, so let's try and get this reference angle. Shift sign, I ignore my negative, and I should get 44.42. Now ask yourself, which quadrants am I dealing with as I go to do this now? Which quadrants is this going to be negative in?
Mr. S,
Yeah.
can you take a question from Katleho?
Yeah, Katlego, go ahead. What is your question?
Good evening, Mr. S.
Hello.
So I just wanted to ask, based on also the quadrant, how do we determine which quadrant it is? Because after the reference angle, after receiving my answer for the reference angle, I'm struggling to find the quadrants. So how do we determine those?
So if you think of the cast diagram, if you think of that, a sign is positive in quadrants 1 and 2, but I don't want quadrants 1 and 2. I want where it's negative, which is quadrants 3 and 4. And so my answer is going to have the form 180 plus x or 360 minus x, but it's going to be in quadrants 3 and 4. Does that help? If I'm just thinking about where is sign negative, you ask yourself, where is sign negative?
Oh, okay. Okay. Thank you, Mr. S.
Pleasure. So my answer here is going to be that plus that, or it's going to be 360 minus that, which is this.
Mr. S, there's a question in the chat if it's okay if they round off to 44.43 instead of 42.
If I looked at the question, so shift sign, let me look at the rounding. I didn't. Oh, you could have, yeah. In fact, you know what? My rounding is wrong here, guys. So actually, to 2 decimal places, it should be 43, because that actually, I was just looking at that very quickly. So you're actually more correct than I was. So well done for picking that up. So we get 224.43, or this is equal to 360. 315.57, and then my final answers would be for the general solution 315.57. Okay, so I'm going to stop there for today, because if I try and throw too much at you on one day, it gets overwhelming. What I know is that if you absorb this method where you find the reference angle, know what quadrants, and then apply the method, that will be a good foundation going forward. Can you get more complicated trig equations? Yes, you can. And I will possibly do a couple of those in the standard class today. And if you're very curious, maybe you can watch the recording. But for now, until you've got this foundation in place, it's no point going to too difficult a question. All that happens really in the more difficult ones is we work for the step to make it simpler. And then we do this method after that. Okay. All right. Benolo, what is your question?
Say, is it necessary to show the quadrant?
You don't have to show the quadrants, but you do have to somehow get to the right answer here. So you need to know what quadrants you get in, but you don't have to do the little step that I do. Level, could I ask you to post the link for the quiz? Because I think some students will be ready to take the quiz now. I'll round off now as best I can, but thank you everyone for today. We got through quite a lot. We will see you next week for some circle geometry stuff. And yeah, go off and enjoy the quiz now. And yeah, hope you enjoyed today. And then Lasanda, let me come to you. I will answer your question to finish.
So,
hello.
So I wanted to know the K substitution. Do you always say K times X times 3x.
Okay, so the normal period of the sine graph is 360, and the same for the cos graph. If you were dealing with the tan graph has a period of 180, And so you would see a 180 on the end. Or if the question changes the period of the function. So if there was a number in front of the x, that number would change the period of the graph. But that's a different type of question. Whenever it's like this, and it's sine or cos, you would have a period of 360 because the graph's period is 360.
Okay, thank you.
All right.